So today we'll solve a numerical from tension member, and this question is from block shear strength. So question says that determine the block shear strength of the tension member as shown. Okay, so this is the figure. In this figure there is a angle section, that is ISA 80 into 50 into 8. So this is 80. From this point to this point it is 80, and this is the thickness. So to make you visualize this angle section, I have a ATM card holder. So try to understand. So if I watch this uh, angle section, okay, this is the angle section now. So here, if I watch this angle section from the top, you will see this. So you will see this from this point to this point, and you will see the thickness. So thickness is equal to the 8 millimeter. Here this is the thickness, okay, and this is 80 millimeter. So this is 80 millimeter, and it is connected with the gusset plate. Suppose this is a gusset plate, this plate is a gusset plate, okay, and there is a 2 bolt here and here, like this, here and here. So yep, and this angle section is used as a tension member. That means you have to apply some tension on this side and on this side, left side. Okay, then the block may tear out from this angle section. Okay, so obviously, so let us come back to the figure. Here, in this figure, uh, you have to find block shear strength. So what may happen if you apply some tension force in this direction, okay, in this direction, then this block, okay, from this point, like this will be the line of failure. Okay, it will go along the center line on the bolt. Okay, and here also it will touch the center point, and then it will shear out. Okay, then you can also assume that this part will shear out. Okay, but it will not happen. Why? Because if I assume that this part will shear out, okay, in this part total area will increase. So it is most likely that when you are having smaller area, that will govern the failure. Okay, so this part will govern the failure. Okay, so block shear means this block will shear out. Okay, so the failure line will be passing from towards this line. That means it will pass towards the center. Okay, then like this. So that means if I say like this, so here there is a bolt here and here, so it will go in this direction. Okay, suppose there is a bolt here. Okay, so it will come to this path. Okay, so assume that there is a uh, so hole, there is a hole. So the block shear line will be passing towards the central line of the hole. Okay, and like this. So I hope you can understand. Now the block will look like this. So this will be coming out from the angle section, and you have to find the block shear strength of this angle section. Okay, now if you can remember uh, the code. Okay, so in this code, in IS 800 page 33 clause 6.4.1, the block shear strength is described. So it is smaller of two values, TdB and TdB. So this is one equation, this is another equation. So you have to find these two values of the block shear strength. Then out of these two values, which will be smaller, that will be the block shear strength of this angle section. Okay, now here you go to the page 33 of IS 800. Then first formula, in this first formula, TdB is equal to AVG into Fy by root 3 gamma m0 plus 0.9 ATN by gamma m1, and on the top it is Fu. second formula it is 0.9 avn fu by root 3 gamma m1, and it is a tg fy gamma m0. So now what is avg, avn, atn, atg? So you have to find this. First one is avg, then second is vn, third is tg, and fourth is tn. Okay, now if this block shear out, okay, in that case we are applying force in this direction, so the line or the area parallel to this force will be the shear area. That means if you see the definition of this vg in this page number, you can see that it is the gross area in shear. That means if you apply force in this direction, then this force is parallel to this line, that means this line. Okay, and you have to find the area on that face, on that cut face. Okay, and that should be the gross area. That means you will not deduct these holes. So what we can do, we can find the total length from this point to this point. Okay, into there will be some thickness of this small element or block, so you have to multiply that also to find the face area on this face. Okay, so it will be so look at this figure. It is 50, and it is from outer edge to center it is 50, from center to center it is 100. So from this point to this point it should be 50 plus 100. Okay, 50 plus 100 into thickness is equal to 8 millimeter. Okay, then avn, so the net area in shear. That means in this equation, in this avn part, you have to deduct these holes. So from this point to this point it is 50 plus 100, so you have to deduct one hole. This is the whole diameter from this point to this point. Okay, and from this point to this point it is half of the diameter. That means, so here the bolt dia is equal to 18, so hole will be 20 millimeter. So you should deduct 20 minus 10. This is for this hole, and this half the whole diameter is for this, from this point to this. Okay, I hope you can understand. Into 8, then atg, that means, okay, so if you apply this force in this direction, then this face will be subjected to tension force, because you are applying some tension. Okay, then so this bc line will be subjected to tension. So you have to find this gross area from this point to this point. That means you have to find this face area. If you see from that side, if you see from that side, okay, so you have to find this area from this point to this point, and this should be gross. That means here in this figure you can see that it is 35, so it should be 35 into 8. You should not deduct the whole. Now in case of atn, you should deduct the holes. That means here it should be 35 minus this half of the diameter of hole. Okay, so it is minus 10 into 8. Okay, now here you know fy, so here fy should be fe 410. So you can fe 410, and bolt grade you can assume 4.6. Okay, so here fy will be 250 mpa, and fu will be 410. Okay, and you know that whenever there is a yield strength, you have to use a factor of safety for the yield strength of 1.10, and in case of ultimate strength you have to use factor of safety of 1.25. So now if you put these values, okay, these values in these equations, okay, so first one TDB1 you will get, I will not show you the total calculation, so I'll just write the answer. So it should be 218.86 kilonewton, okay, and uh, TDB2, that means this one, it should be 231.34 kilonewton. Okay, let me show you one value. Okay, so this TB1, let me show you this one. So TDB2, okay, 0.9 into AVN, it should be, okay, let me see, 984 millimeter square. VG, it is 1200 millimeter square, and it is 280 millimeter square, and it will be 208 millimeter square. So AVN, it will be 984 into 410 by root 3 into, as I have used 410, that means ultimate strength, so we have to use 1.25, okay, plus ATG. ATG means this one, 280 into 250 by 1.10, okay, and you should multiply 10 to the power minus 3 to convert it into kilonewton. So it will be 231.34 kilonewton, okay. So so out of these two values, smaller one is this one, so the block shear strength of the angle section for this arrangement will be 218.86 kilonewton. So I hope you have understood, and if you don't understand, then I will recommend you to go through the previous lectures and the lecture notes, and then try to understand.